Action potential occurs when a stimulus affects the body or occurs in the neuron. When it's stimulated, the cell membrane will allow ions to move across. And obviously this changes the resting potential. Depending upon the type of stimulation that it receives, it can change it a lot or it can change it just a little bit. So if you put your hand on the stove and you burn it, that's going to cause a very drastic change in the cell potential. It'll be a drastic stimulus. But if it's somebody who just bumps into you or whatever, maybe not so much. So when you have a strong stimulus, this can change your membrane potential from minus 70 it goes from minus 70 millivolts. That's your resting potential, and it can go up to plus 30 millivolts. That's a big change in your cell potential. Because your membrane changes and allows these ions to move across, all right, it's going to go from this negative potential to a positive potential. So that cell membrane will allow positive charges to come into the cell, greatly increasing the membrane potential. And that's what activates the neuron. Let's see, I have a figure here. This is a plot, and you have a similar plot in your book, of the membrane potential. So here, your cell is at minus 70, has more negative charges in it than positive charges. And somewhere along the way, you get a stimulus that's applied to it. And if it reaches above a certain threshold, that stimulus, if it comes up to minus 55, then that causes this sort of runaway voltage, where you get this voltage rising, and then it drops. You have this certain area where it's actually below the membrane potential, the resting membrane potential, and then it comes back to its resting potential of minus 70. So you have this very sharp rise in the voltage of your membrane, or of your cell body, where it goes from minus 70 to upwards of plus 30 millivolts, which is a pretty big change in the potential, just due to bringing these positive charges in. The way this works, it's not really the same way as we have for when we think about electrical current. You'll have this that'll sort of go in stages. So here, you'll have these charges. This is where your stimulus is being applied. This is sort of a cross-section of your cell. You have these charges that are coming in. So here, I have a positive potential right here, and it's going to go down the body of this cell in a wave. So this plot shows the recording voltage at this point. So at this point, this cell body has a negative resting potential of minus 70 volts. But coming down the wave of it, I have this positive potential here. So at this location, I would have a resting or a potential that's bigger, a positive potential. Now, when it comes here, this sort of wave of activity comes, or the stimulus comes, and causes the voltage, because these positive charges are coming in and negative charges are going out. I get a positive potential here, which shows our voltage here. And then after it goes past, it returns back to its normal. So you have this, it's not in the same as electrical current in a wire that we think about where these charges are moving sort of in a straight line. You actually have this interchange of ions all along the body. I'll send you this figure, but they talk about it in the book as well. This sort of wave of ion exchange, which causes this change of potential. This is called an action potential. can also have a graded potential. And a graded potential occurs in response to less severe stimuli. This occurs much more slowly. So the action potential occurs really quickly because you need it to, right? If you have this dangerous stimuli that's being applied to your body or whatever, you need that to occur very quickly. And so those neurons act very quickly, that action potential. But if you have something that's less severe, it causes a graded potential, and your cell potential or your membrane potential might not get quite as high, and it doesn't occur quite as quickly as the action potential does. All right, I think that's it. I was going to leave out the section on applications. That's on page, there's not much in it, but page 171 to like 173. That's EKGs and various things, so we're not going to do that. But you're learning from this one of the basics of the neuron. I'll go back and read your book as well, and I'll send you these various things. Even though the basic parts, that's sort of a basic idea of how they work as well. I think that most people probably know that fairly well. Is that correct? Covered a lot of material this semester. Normally in a class, in a physics class, we would only cover like the first 2 chapters that we did in an entire semester. So it's all been very sort of broad brushstrokes, but we covered a lot of topics in this class. Let me get your quiz. All right, if you could do your ID number on the back, please. Appreciate it. And we only have 4 county quizzes, so if you don't want to take this one, that's fine. Just let me know. But it's good practice.